Let's get it. All right, so I've been gone for a bit. I went on vacation. It was nice. It was relaxing. Lived a little bit light. But while I was away, I looked at the source code for one of the CSV crates, and it was pretty crazy. They were doing things with like finite automaton and DFAs, which is deterministic finite automaton. And I was like, I haven't written one of those, so let's try it. So yeah, this video is going over DFAs, or you could just say finite automaton. Doesn't really matter, at least not in my mind. Yeah. All right, so like always, we're going to start with definitions. But before we do that, I just want to mention that the first sentence of the Wikipedia page is a little wordy, so just bear with me. So here we are, deterministic finite automaton. In the theory of computation, a branch of theoretical computer science, a deterministic finite automaton, also known as deterministic finite acceptor, deterministic finite state machine, or deterministic finite state automaton, is a finite state machine that accepts or rejects a given string of symbols by running through a state sequence uniquely determined by the string. Whew. That was wordy, but more or less there are a lot of different names for this. People call it a lot of different things, and it boils down to just being a finite state machine. So we should probably go to that page because that has a better definition. So finite state machine. A finite state machine, or a finite state automaton, or simply a state machine, is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at any given time. The finite state machine can change from one state to another in response to some inputs. The change from one state to another is called a transition. So based on that, you sort of get the idea that we have a bunch of different states. There's going to be a state that you start out at, obviously. And then based off some input, you move to a different state. And then based off another input, you move to a different state or the previous state. You're just alternating between these predefined deterministic states. And then the example they give, and the classic example, is the turnstile with the coin operator. And this is sort of like a visual example. So if you look here, right, we have a turnstile. And in a turnstile, if you try to push it, like it starts off locked, right? Yeah. All right, so if you look here, here's the turnstile. It starts off locked, initial state. And if you try to push it while it's locked, it remains locked. However, if you put a coin in, then you move to the next state, and it becomes unlocked. If you put another coin in while it's unlocked, it remains unlocked. If you push it while it's unlocked, it pushes, it rotates, and then becomes locked again. And then you can just go through the process all over again. Like these are your two states, and the inputs that you have in this machine or this world is push and coin. So taking this idea and trying to apply it to Rust and to a different problem, because I didn't want to build a turnstile, I went about trying to write a DFA, FSM, DFA, all the acronyms. I tried to write a state machine for parsing quotes out of sentences. All right, so now that I got my terminal out, what I'm going to do is I'm going to show you the source code for a bit, and then I'm going to run the main program so you can see it in action, and then we can start dissecting it and looking at how it was actually built. The main. So coming back to that stuff. So I have this string, and we can see that it starts as a string, and this string has quotes in it. Like, Marcus said, "Yo, have you eaten?" I replied, not yet, I'm currently looking for food now. How about you? And I have one string with two sets of quotes in it. Yo, have you eaten? And not yet, I'm currently looking for food now. How about you? So what I want my finite state machine to do, or DFA, is to look at this string and then only return back the quotes that are within this string. All right, so let me run the example so you can see it in motion. Cargo run. All right, so here in saved, and I just printed out the structure I have for my DFA, or collect quotes, right? Here in saved, I have the first quote, yo, have you eaten? And then the second quote, not yet, I'm currently looking for food, how about you? And the state that it's currently in is in right quote state. All right, so now that you see that it does what it's supposed to do, let's figure out how I went about doing it. All right, so one of the first things you have to write out in terms of finite state machines are your states. And here I have three of them. I have my left quote state, I have my right quote state, and I have my ignore state. And my ignore state is going to be the one I start off in. More or less, in terms of the process I'm using to parse the quotes out of a string, I am starting at ignore. And then I'm processing one character at a time. And if I see a left quote, then I move to the left quote state. Now, while I'm in the left quote state, I want to start saving things because this is the content that I care about. So while I'm in left quote state, as long as I do not see a right quote, I'm saving. I'm putting things in my buffer. I'm just holding it till later. And then when I see a right quote, I'm saying, oh, my buffer is done. I can now move that from buffer to saved and hold on to that as a full quote. And then after that, I'm either going to go to left quote stage or the ignore state. Because, I mean, after a right quote, you can actually have another quote or you can have a character that you want to ignore. So that's more or less what we did in terms of like a high level overview. So if we scroll down a little bit more, I have my struct for collect quotes. And this has the buffer, which I was talking about, where if I'm in the left quote state, then I just want to add things to the buffer. And then I have saved, which is a vector of strings. So when I hit the right quote state, I'm going to end my buffer and move whatever is in my buffer to saved as an entire string. And then lastly, for collect quotes, I have the different states that I can be in, which is pointing directly to my enum, which only has the 3 states. Oh, as a heads up, one thing I forgot to mention is I made this work for both English and Chinese. Chinese is my second language, but more importantly, I was curious about how do you go about processing a string when it is UTF-8 and each byte is not ASCII. Like, so for Chinese, I think it's maybe 3 bytes before you get a full character. So I'm just curious how to tackle that problem. But you'll see how it's done. Anyway, my collect quotes has a few methods on it. One, I need to be able to identify if something is a left quote. So I can pass in the string here, and then I can check it with these 2 different types of left quotes. Here's my ASCII one for English, and here's the one I have for Chinese. And if it is in that list, then I'm returning true, because this is just a Boolean, true or false, right? And I do the same thing for right quotes. I take in a string, I check it against my list, and if it matches one of them, I return true. And then I have the classic, the helper, the create a new collect quotes. And this is how I go about doing it. I create a new buffer, which is a buffer, it's just a string. I create an empty list for saved. And then the initial state of collect quotes is ignore. All right, so here's where it gets a little bit tricky. I have 2 different methods for, well, one method and one function for processing. This processes one single string at a time, right? So this is when I take in the string and then analyze it. So if I'm taking in a string, you can see it at the top here. I'm looking at what state I am in, and then based on my state, I am going to do a set of actions. So let me go to the first one, right? If I'm in ignore state currently, okay, then I will check to see if it is a left quote. If it is a left quote, then I will switch states and go to the next state, which is left quote, and I will start adding that item to my buffer. If it is not a left quote, I am not going to do anything. It's just going to go to false and just continue onward. All right, so the next section is, if my current state is a left quote, what do I do? Well, I'm going to check to see if the item being passed in is a right quote. If it is a right quote, then I'm going to change my state from left quote to right quote. I'm going to push that last item into the buffer. I'm then going to move everything from the buffer into saved. And then I'm going to clear the buffer so that I can start the process over later again. If it is not a right quote, then I'm just going to keep adding to my buffer, which means like I hit a left quote, and now I'm just hitting the content of that quote. And I'm just adding it to the buffer. And then my next state and last state, if I am in a right quote and I see an item and that item happens to be a left quote, well, so one thing you should keep in mind when you think about right quote, I moved into right quote once I saw a right quote. So this is the character immediately after that right quote. And if that character immediately after is a left quote, then I'm going to start, then I'm going to transition from right quote directly to left quote and start adding stuff in to my buffer string. If that character immediately after the right quote is not a left quote, then I'm going to move my state from right quote to ignore and then proceed onward. So those are my 3 different states, and that's how I process a single character. So the next part you have to think of is, this is processing a single character. I need to be able to pass in a string, like to continuously go over one item, and just pass it into here, right? So that is my process string function. So here I've taken the initial string and I'm passing back collect quotes. I take the string as bytes because I need to look at everything as bytes. I initialize my collect quotes, which is my DFA. This step is for handling the UTF-8 stuff. So like I was saying earlier, if you're writing in another language that's not ASCII, then it's highly likely that a single byte is not going to be equivalent to a renderable string or a valid UTF-8. Sometimes it will take multiple bytes. And I think for Chinese it might be 3. Don't quote me on that, but more or less, if you're in a state where you have bytes, but they're not valid UTF-8 yet, then what I did here was I created a temp storage place to put those bytes, and then I keep adding those bytes until the sum of bytes equals a single valid UTF-8 string. Or, in theory, it's like a char, but not really, not from a technical sense. But y'all get the picture. Anyway, so I'm coming down. I got the price. I am processing 1 byte at a time. And here's where the work is being done. 4-byte in string, right? I'm unwrapping the byte. I'm pushing the byte to temp. And then I'm doing a match on string from UTF-8. And this is where I do the check. So if the bytes in my temp storage place, if they can be rendered to UTF-8, if they are valid UTF-8, then we get an OK. And then I can pass that character into my DFA. But if it does not register as valid UTF-8, then I get an error here, and then I could just continue on. Right? Next iteration, I push the next byte in, and that will maybe get me to a valid UTF-8. And that's how I dealt with doing this in Chinese. All right, so going a little bit more in detail, if I have a valid character, then I will pass that character into process, which we already looked at, and then I will clear my my temp buffer. Cool. And then at the end of this process, I just return the DFA. And that's what you saw when I ran the program and it just printed out. So I kept saying I made this work for Chinese. I actually have a test example that I just want to show you. I didn't want to say it and not prove it. So let me scroll down to here. That's my English one. Oh, here's my Chinese one. So here's my test string. If you can read it, you can. If you can't read it, I guess I can. 老杜问了我，你吃了吗？我喂了，没有啊，你呢？ More or less, person with name asked me, have I eaten? And then I replied, I haven't. Have you? So that's a string, and there are 2 quotes. You can see them here. One from there to there, which is 你吃了吗? And then another one right here, which is from here to here. 没有啊，你呢? And then you can see that I'm process string, which we already walked through. And then I'm looking at the save content, just asserting that the saved first item, asserting that the first item in the saved list is 你吃了吗? And the second item in the saved list is 没有啊，你呢? So let me run my test real quick. Cargo test. Oh, cargo test. And you can see my test pass. But meh, I mean, there's not really output there. All right, I want to take a step back and do one last thing. I want to print out like a debug line so you can see how everything gets processed, step by step by step. So let me come up here, and in the process char or process method where I just do for one character, I'm going to print out the item that I'm looking at. And I'm going to print out self as well, so we can just see it go through. And then I'm going to run the main. And let me scroll to the top. Keep going. Oh, here we go. So here you can see the words, every item at a time. So Marcus, I'm in state ignore. I'm still ignoring. Said, still ignoring. This was the item that came in. It was a left quote. I am now in left quote state. And then said, yo, have you eaten? And you can see my buffer is growing because now I'm in the state where I'm capturing everything that's within the quotes. And let me get to eaten. And then here you can see the right quote. And we make this a little bit smaller so it's easier to see. So just going over it again, Marcus said, yo, scrolling down, have you eaten? And then here, we now switch states to right quote. And everything that was in buffer has now moved to save. And buffer is now empty. All right, moving onward. I'm ignoring. And then I see a left quote again. So I'm just changing states again. Going to left quote. And now you can see my buffer is growing. And I make this smaller again so it fits in the screen. Here we go. Not yet. I'm currently looking for food, I think I said. But you can just see the buffer as it grows. Let me make this a little bit smaller. I'm currently looking for food. How about you? And then here you can see at the last one, I go from left quote to right quote. And then if I had another character after that, it will either go to ignore or left quote. You can't really see the right quote because my head is in the way. There we go. Right quote's right there. All right, so we've reached the end of the video. I personally haven't done much with automaton, like ever. I think I messed around with it once way back when, a long time ago, in a very far distant land. But it was nice to revisit it. And I hope you all enjoyed the video. If you did, like, subscribe, yada, yada, yada. Till next time. Peace.